Okay, picture this. You're staring at a radar screen. It's totally blank, but you have this chilling feeling that something is out there watching you, and it can see you, but you can't see it. Now, this isn't some kind of sci-fi movie plot. This is the very real and very deadly world of stealth technology. And today, we're going to break down exactly how it works. So let's just get right to it. How on earth does a massive multi-ton jet screaming through the sky faster than the speed of sound just disappear? Is it actually invisible? Or is it playing an unbelievably clever trick on our eyes and, more importantly, our technology? That's the big question we're tackling. To figure out how to be invisible, first you have to know what makes you visible in the first place. And for any aircraft trying to stay hidden, the number one enemy is radar. The basic idea is super simple, right? A radar station yells a pulse of energy out into the sky, and it just waits. If that pulse hits something and an echo comes back, you're caught. But here's where it gets really interesting. Radar doesn't actually care how physically big a plane is. It cares about something called the radar cross-section, or RCS. And if there's one thing you need to know about stealth, it's this. RCS is basically a measure of how loud that radar echo is. You can think of it like this. To a radar, a normal jet is like a giant roaring bonfire. A stealth fighter? It's like a single match. And the whole game for a stealth designer is to make that tiny match flicker out completely. And just look at this comparison, it's absolutely mind-blowing. A typical fighter jet might show up on radar with a signature the size of a big van. But a stealth aircraft? Its RCS can be smaller than a bird's. I mean, let that sink in. We're talking about making a 20-ton war machine appear, from a radar's point of view, smaller than a pigeon. So how in the world do they pull off this incredible shrinking act? Well, it's not just one thing. It's a whole system of solutions. But the biggest one, the one that accounts for something like 80% of the effect, is the aircraft's physical shape. The geometry is everything. The best way to think about it is like this. A normal airplane, with all its round parts and flat surfaces, is basically a perfect mirror for radar. When those radar waves hit it, they bounce right back to where they came from. It's like shining a flashlight at a mirror in a dark room. You immediately see the light bounce back at you. A stealth plane, on the other hand, is designed more like a cut diamond. All of its angled, faceted surfaces catch that radar signal and scatter it in 1,000 different directions, anywhere but back at the radar operator. That flashlight beam gets shattered and sent harmlessly off into the darkness. And of course, the absolute poster child for this is the legendary F-117 Nighthawk. The reason it looks like something from another planet is because it was designed by supercomputers with one and only one goal: be the worst possible mirror for radar. Every single angle on that jet was calculated to bounce energy away from its source. All right, so deflecting the radar signal is step one. But what about the little bits of energy that don't get scattered perfectly away? Well, for that, you need to have a very, very special kind of skin. This is the next layer of our invisibility cloak. And this is where something called radar absorbent material, or RAM, comes in. The surface of a stealth aircraft is coated in these really special paints and materials that have things like ferrite and carbon mixed in. And instead of reflecting the radar waves, this skin, well, it pretty much eats them. The electromagnetic energy from the radar gets absorbed right into the material, and it's converted into a tiny, completely harmless amount of heat. The echo never happens because it gets swallowed whole. But you know, defeating radar is only half the battle. You could be a complete ghost radar, but if you're flying around with 2 giant blowtorches strapped to your back, you're still a pretty easy target. Modern heat-seeking missiles are incredibly good at what they do, so you also have to hide your heat signature. And engineers have come up with some seriously brilliant ways to do this. If you look at an aircraft like the F-22, you'll see the engine nozzles aren't round like on most jets. They're wide and flat. That shape helps spread out the heat. Before the hot exhaust even leaves the plane, it's mixed with cooler air from around the engine. Then the exhaust is often directed upwards, away from any heat sensors that might be looking up from the ground. The whole idea is to make the plane's heat signature blend in with the background temperature of the sky, turning it into a ghost for infrared systems too. Okay. So we've handled radar and we've handled heat. Now we get into the really subtle stuff, the things that are just as critical but a little less obvious. This is all about what's hidden deep inside the plane, and maybe more importantly, what the plane doesn't do. So here's a massive weak spot on any jet, the front of the engine. Those big spinning fan blades, they're made of metal and they're curved in just the right way to be a giant flashing mirror for radar waves.
The solution is so simple, but it's genius. You just never let the radar get a direct line of sight to the engine face. The air intakes are curved in a deep S shape, so radar waves might go in, but they just bounce around inside and never ever get out.
And another huge one. On a normal fighter jet, you see all the missiles and bombs hanging off the wings. Well, for a stealth aircraft, that's a complete disaster. Every single pylon, every missile fin, every bomb casing creates a new little surface for radar to bounce off of. It just ruins the whole effect. That's why on jets like the F-35, everything, and I mean everything, is carried inside internal weapon bays. You pop the doors open, drop the weapon, and close them again, keeping that outer profile perfectly clean. And finally, there's maybe the most disciplined part of flying stealth, electronic silence, or what they call EMCON. Think about it. If a stealth jet turns on its own powerful radar to look for enemies, it's like someone screaming in a quiet library. You instantly give away your position to everyone. So instead, a stealth aircraft acts like a predator. It uses incredibly sensitive passive receivers to just listen for the enemy's electronic signals, their radars, their radios, and it uses that information to build a perfect picture of the battlefield without ever making a sound itself. Now, after all of this absolutely incredible technology, it is time for a little bit of a reality check. Because as amazing as stealth is, it is not, and this is important, it is not a magical cloak of perfect invisibility. It has weaknesses, and it has limits. And that's a really critical distinction to make. See, the goal isn't to be truly Harry Potter-style invisible. The goal is to shrink that detection bubble so much that by the time an enemy might, just might, get a lock on you, you've already done your job and you're on your way home. For example, certain types of low-frequency radars can sometimes get a better return because their longer wavelengths just aren't as affected by the plane's special shape. And like we said, the second you open those weapon bay doors, your radar signature briefly flashes like a beacon. Plus, that delicate, super expensive radar-absorbent skin, a little bit of damage, or even just heavy rain or dirt can make it less effective. Stealth requires perfection, but the real world is always messy. And hey, this isn't just theory. Back in 1999, during the conflict in Yugoslavia, an American F-117 Nighthawk was actually shot down. So how did it happen? Well, it was a perfect storm of factors. The Serbians figured out that the jets were flying the same predictable routes night after night, so they waited. At the exact moment the F-117 opened its bomb bay doors, its radar signature bloomed. An old, supposedly obsolete low-frequency radar system, operated by a very clever crew, got a lock and fired. It was a huge wake-up call that even the best tech is vulnerable. So when you really step back and look at it like this, you see the true genius of the whole concept. Stealth isn't one trick. It's a complete philosophy. For every single way an enemy could possibly try to find you, with radar, with heat, with their own eyes, with electronic sensors, there is a complex, layered solution designed to counter it. It's this incredible system where every single piece has to work in perfect harmony to create a ghost in the machine. So why? Why go through all this trouble? We're talking billions upon billions of dollars, decades of secret research, incredibly difficult maintenance. It all boils down to a very simple and very brutal truth of warfare. The one who sees first wins. Stealth is about giving you the power to be the one who sees first every single time. And that, in the end, is really the main takeaway. Stealth aircraft are not invisible. That's not the point. They are designed for a much more practical and much more deadly purpose, to make absolutely sure that by the time you finally see them on your screen, it's already too late.